Hello everyone, welcome back. Today we are going to be solving some logarithmic inequalities, starting with this one here involving log, and then moving on to this one involving ln. So let's dive in. Okay, so my first step here that I need to do in order to get rid of the logarithm form is I need to switch this form to exponential form. So recall that what the logarithm is of, which in this case is x plus 5, must be less than or equal to the base to the power of the answer. So in this case, 3 squared. And so this is the equivalent exponential form of the logarithm. And then we need to solve this. So that means that x plus 5 is less than or equal to 9, which means that x is less than or equal to 4 if we subtract 5 from both sides. Now, if we had just started with this line, if it hadn't originally been a logarithm, we'd actually be done right here. We could say x is less than or equal to 4, and that's the final answer. But in this situation, because we started with log, we actually need to also ensure that the value inside our log function is going to be greater than 0, right? Because recall that a logarithm cannot take 0, and it also cannot take a negative value. So therefore, x plus 5 must be greater than 0. And if we subtract 5 from both sides, we'll learn that means that x must be greater than negative 5. So that means x must be greater than negative 5 and also less than or equal to 4. And so the final solution is that x is between between negative 5 and positive 4, including 4, but not including negative 5. All right, here we have a strictly less than sign. Here we have a less than or equal to sign. Okay, let's try the second one, which involves ln. So how do we get rid of ln? Well, to get rid of ln, we would have to use e, right? We would write this in exponential form. And so we would say e to the power of ln x minus 2 is less than e to the power of 3. And then ln and e cancel each other out, and so we end up with x minus 2 is less than e cubed, and then we can add 2 to both sides. And once we do that, we get that x is less than e cubed plus 2. And so that would be approximately 22.0855. So I'll put that this is approximately, x must approximately be less than 0.0855 plus 2. So therefore, x must be less than 22.0855 approximately. Now, this is not exact. This is an approximation that we've done here because keep in mind that e is irrational. The other thing is that ln cannot take a negative value or 0. So that means that x minus 2 must be greater than 0, which means x must be greater than 2. So therefore, the final solution is that x must be between 2 and e cubed plus 2 if we are to use exact form. If they want a decimal approximation, though, then we would write that it must be between 2 and approximately 22.0855. And there we go. All right, well, that's it for this one. Please let me know if you have any questions, and we'll see you for the next one.